Welcome to C++tutor.com. This is a production of YouTube channel Learnorama and the Facebook page Awesome C Programming Tutorials in High Def. Today we are going to learn about abstract data types and data structures. Remember, this is not a C programming tutorial. This is not a C++ tutorial or Java tutorial or anything like that. It's totally independent of programming language. We are just going to talk about the concepts of data structures and ADTs, abstract data types. So no matter what language you are working on, this tutorial is going to be good for you if you are dealing with data structures. Anyway, so the question is that what is an abstract data type? You will find all kinds of definitions, but essentially what abstract data type is, that it is the collection of data whose implementation is hidden behind the operations defined on it. So let's take an example to understand what I just said. Okay, it's always easier to explain and understand with examples. So let's suppose that you are writing a program that actually manipulates the scores of the students in class. Okay, this is my favorite one. I always take that example because it's very simple. So suppose that you're writing a program, then you want to that involves or that manipulates the scores of all the students in a class, and those scores are anywhere from an integer from 0 to 100. So and suppose there are like 20 students, right? So what you will have is numbers like this: 92, 64, 85, 28, 98, and so on. And the 20th number would be, I don't know, 85. Now what's going on here? I mean, if you look at it, you have 20 integers, right? Over here, what would you call it when you just look at it? What would you call it? I would call it like, I don't know, like list of scores, list of integers. The keyword is list. This is a list of numbers, right? So list is a data type. It's an abstract data type. Why? Because you don't care how you're going to implement this list. It's data to begin with. It consists of, it's a collection of data, and you don't care. It's been abstracted. You don't care how you're going to implement it. At least at this point, at this level, when you are analyzing your program, how you're going to be writing the program, what problem you are trying to solve, you have to manipulate this this list or list of scores or whatnot. Like you have to find out who is the number one in the class, right? Who has the highest score in the class, right? So you will have to manipulate this list to figure that out, right? But you don't care about this at this point. You're just trying to understand what your problem is, and what you have is a list of these integers here. This list is an abstract data type, ADT, because you don't care how you are going to implement it, at least at this point. You don't care about it. You just know that you have a list that you are going to manipulate. You are going to do something with it. So this fact that you have a collection of data and its implementation is totally hidden makes this list an ADT, an abstract data type. But there's something else. There is one more thing. What's the use of having data if you cannot operate on it, if you cannot manipulate the data? There is no use. I mean, that's what we do. We just manipulate data everywhere, right? So the fact that you are going to do operations on this data is essential part of an ADT, right? So wherever there is an ADT, you will have at least one operation defined on it, right? For example, in this case, for list, we have like, let me write it underneath it. List, we have, for example, you can sort this list, right? So sorting would be an operation defined on this list, right? So essentially this list is the collection of data whose implementation has been hidden behind sorting, and many other operations that you could do on this list. So an ADT, an abstract data type, is essentially a collection of data whose implementation is abstracted or hidden behind the operations which are defined on it. That's what ADT is. Very simple, right? Now data structures is one step further. I mean, there is a very, a lot of people use ADT and data structures as synonym, okay, but they are, strictly speaking, they are not, but they are very similar, so you could still use them. If you are loosely using them, using the ADT and data structures, you could basically, definitely interchange them, but there is a very subtle but extremely important difference between the two. One just talks about the abstraction, it doesn't care about implementation. The other one tells you, data structure tells you how you are going to represent the data, how you are going to store the data, how you are going to organize the data. In other words, it will give you the way or ways to implement this list. So for example, if you want to implement this list, forget about data structure, forget about ADT. If you have this problem, we have been doing this all this along, in other tutorials. If you have this to represent this data, this list in your program, what are you going to choose? What data structure you're going to choose without knowing that it's a data structure? First thing that comes in mind is, of course, an array. Yeah, an array is a very, we studied about it, we used it, we talked about it. It is essentially a data structure. Why? Because it shows you exactly how you are going to represent this data in your program, okay, as an array. It will be bytes allocated in the memory, and this is how you're going to store all this information here. So an array is essentially a data structure. So what is a data structure? It's one step further. It actually defines the physical implementation of the data. It is essentially the way to store and organize the data. It's a particular way of storing and organizing a data, a collection of data. And just like ADT is associated with operation, sorting. All you say that this is sort. The operation of sorting is basically to order these numbers, right? You don't care about how you are going to do sorting at this level when you are talking about ADT. But when you are talking about data structures, you talk about the exact process that you are going to use to do the sorting. So you talk about the step-by-step instructions that will result in ordering this data. And that step-by-step instructions to perform a task or to perform a particular operation is called an algorithm. Okay? And when you talk about data structures, you always talk about algorithms which are associated with those data structures. For example, sorting algorithms, and there is not just one sorting algorithm. There are many sorting algorithms here. So they are all, for example, insertion sort, selection sort, I don't know, like quick sort, and there are many more. All these algorithms are actually defined on this array, can use this array and manipulate the arrays, and their end result is going to be sorted list. And this algorithm is going to give you exact detail that if you follow blindly, you will end up in a sorted list. So that's an algorithm, and it's an essential part of data structure. So we are going to talk about algorithm as well when we are talking about data structure. So data structure is the way to store and organize data along with the algorithms defined on it. And the same list could be implemented using some other data structure. For example, a linked list. Okay, its linked list is the way to store or represent or organize this list. If you talk about linked lists, you can definitely store all this data in your program easily if you know how to implement a linked list. Okay, so linked list is again another data structure, and it has the same kind of algorithms defined on it too, like insertion sort, selection sort. I mean, you could use these algorithms on linked lists also. The steps will change, but essentially you could do that. You can still sort a linked list. Okay, so that's what a data structure is. So I hope you understand that what ADT is, what linked list is, and what the difference what ADT is and what data structure is, and what is the difference between an ADT and data structure. To recap, an ADT is the collection of data whose implementation is hidden behind the operations defined on that collection. And a data structure is a particular way of storing and organizing data along with the algorithms defined on it. That's what ADT and data structures are. I hope you understand. If you like this tutorial, please don't forget to give a thumbs up, and don't forget to visit c++tutor.com, and don't forget to subscribe to the YouTube channel. Keep watching.